So welcome everyone to this webinar that we're going to be running today around harnessing the power of data with AWS. My name, as you can see on the slide, is Raj Bhadresa. I'm a champion AWS Authorised Instructor delivering training courses for bespoke training services. And my goal, if you like, my mission for this session today is really to give you an opportunity to find out more about the various services that can support your data journey in AWS. If I can start with a brief introduction and maybe a little bit of housekeeping so everyone's aware of what the plan is for the session. I'll whiteboard this because it'll make my life a little bit easier. So in terms of timing, if I can just call that out first, I expect the session will take about an hour, maybe a little bit longer if there's going to be Q&A that we'll have at the end. So roughly about an hour. So I'll go through the full session in the hour. The content itself is not available in terms of the content I'll be presenting, so I won't be able to share the slides with you. However, my colleague Fiona, who's going to be behind the scenes doing a lot of work for us, will be recording the session, and you'll get a saved version of the recording after. So like I said, I can't necessarily save or provide for you the content I'm working from, but of course it will be recorded, so you can always review the content afterwards. I'll also be sharing some links as we go through the session. That, I think, is the main things to call out. But actually, I think Fiona's also just given me a little bit of a reminder. If you have any questions, please feel free to use the chat window. So dig out the chat window, send any links. I've got it active in my screen here so I can respond to any of the messages that you're sending through as and when. So you don't need to raise your hands or do anything else. Just pop your questions directly into chat. And maybe even before we do that, I'll do a brief introduction so you have a little bit more of an idea of who I am. And I will cheat a little bit using my stock standard introduction used for most training courses. So bear with me a second as I just pop this into the chat window. So if you have access to the chat window, this is me in a brief nutshell, my background, if you like. And as you can see there, been in the industry for a while, and my dad joke that I use when I'm introducing myself, the name is Raj, but you can use my surname like someone who doesn't dress well, or you can pronounce my surname like someone who doesn't dress well. It's a dad joke. Stick with Raj if ever you need to call me that. But I've been working with AWS Technologies for 5+ years and been working with Bespoke for 4+ years, delivering various training courses. My background is predominantly in IT infrastructure, which is interesting because that IT infrastructure background I've had as I've moved to the cloud has really given me an option to move into data, machine learning, artificial intelligence. So it's really helped them kind of give me other opportunities beyond just kind of core infrastructure, but certainly not from a developer background. My expectations, cheesy though they may sound, is to meet your expectations. And if I can set the expectations, hopefully over this hour, you'll get a good grasp and a basic fundamental understanding of some of the data services that may support you in AWS on your data journey. And then lastly, just sharing something personal. I'm based in New Zealand, so I live in Auckland, Aotearoa, New Zealand. I've been here for about 20 years, having moved here from the UK. The reason I also mentioned that I'd like to tell you about myself, I'm working from home, as some of you may be. Maybe you're in the office. I've got 2 dogs and a cat. I'm hoping for the next hour or so they'll be quiet. They generally are, but there could be a few exceptions. So apologies if there's any craziness that goes on in the background. Maybe also to get a bit of a feel for you all, maybe if you could share a little bit of information in the chat window, maybe where you're located, what your job role is, something simple. If you could just say, hi, and your name, and I'm living or I'm based or working in, and then of course, wherever you are. I'm assuming most of you are either in Australia or New Zealand, but yes, feel free to share a little bit of information about yourself before we start the session. Just gives me a little bit of an idea where you're all from, what your expectations are, possibly. Doesn't have to be a full life story like mine. Fantastic. Thanks, Etienne, for kicking things off. Based in Wellington, in cloud operations. Fantastic. Welcome to the session. Tantar, if that's the right pronunciation, from Sydney. Fantastic. So far we've got, okay, so also Ade, if that's the right pronunciation, based in Tasmania, okay, software developer, fantastic, welcome to the session. Sam, Department of Transport and Main Roads, based out of Brisbane. I think I've met a few of your colleagues, possibly, I don't think I've met you, Sam, I may be wrong. Fantastic, welcome. Karen from Adelaide, okay, head of software, welcome. Greg in Newcastle in BI, fantastic, in Service New South Wales. Niket, welcome. Commonwealth Superannuation Corporation, CSC, okay. Canberra, DevOps consultant, data science enthusiast. Fantastic. Good. So fantastic. Thanks for sharing a little bit of information about yourself. Feel free to keep posting that through. But as you're doing that, I might just move back to our content And I've got a bit of a feel, I guess, now for where some of you are located, and of course, some of your backgrounds, various backgrounds, as would be expected here. But really, I guess, given what you've already told me with regards to where you're based and what kind of organizations you're working for, thinking about maybe what your customer requirements are. And maybe it's going to be something that you can see on the slide here. So maybe some of you are commercial organizations, maybe some of you working in the public sector, some of you may be working for partner organizations. And I guess your requirements will vary depending on what your customers' requirements might be, whether that's internal customers, external customers, etc. But I guess what's driving some of the decisions that you can potentially make is data. And I know it sounds a bit of a cliche term, but data is all around us. And you'd be mistaken for thinking, of course, it's all artificial intelligence and machine learning. But of course, one of the foundational elements, of course, to provide and support those kinds of AI and machine learning discussions is going to be around having a good data strategy. And that's really the important point, I guess, we're trying to get across today. So with that in mind, really, we need to understand the AWS modern data strategy, because that will help you to understand your customers and their requirements. And that's really what the session is about today. And what that involves with this AWS modern data strategy, it's making sure that you know how to take care of that data. So having somewhere to store it, making sure it's accessible to those who need to have access to it. And that's, again, quite a critical part from a security perspective. And of course, a couple of you mentioned out that of course, you're in this analysis space, maybe performing business intelligence. So being able to perform that analysis and then make those data-driven decisions as need be. And, for regardless of what your data might be, so the data types, whether that's structured data, unstructured, semi-structured data, so the various data types, but having a central place for you to interact with that data, and of course, then be able to perform the analysis as need be. And if you want to find out more about unlocking the value of your data, there's a reference that I'd like to share in the chat window. I'll just grab this from off screen. So AWS for Data, this is actually quite a good landing page. I won't jump in and show you this now, but if this is something you think you want to go into a little bit more detail around, the general concept, if some of you are in a kind of a strategic role that is thinking about data and its requirements and considerations, there's a link into the chat window. I will be posting links every so often, but if I move forward, the AWS modern data strategy looks something like this. At the center of this particular picture, as you can see, is having the data lake. And the data lake provides either the source or the destination to interact with your other data services that you may be working with. So whether that's, as we go around the circle starting from 12 o'clock, whether we're talking about relational databases, classic databases that some of you may have worked with if you've either been a database administrator or you are a database administrator. So those relational databases can still be critical to your organization. Non-relational or NoSQL databases, again, could also be something you may need to consider or you may be implementing. And part of the driving reason for having a data strategy may well be that you want to actually interpret and analyze that data using, as some of you are doing, maybe business intelligence tools, but also machine learning, artificial intelligence. So we're going to really, again, just thinking about the ML part of the equation. Data lake, not necessarily replacing the idea that maybe if some of you have been in the industry for a while, the idea of a data warehouse, but potentially complementing what you're doing with your data warehousing strategy, and then having tools for log analytics and big data processing. Now, I'm going to be filling out these particular circles as we progress through the session today, really just telling you a little bit about the services that can provide that capability. But again, if you want to find out more about this data strategy, let me share a link into the chat window that may help you build on top of that. So let's move forward and start to focus on some of the services. And I guess the big part of the equation, as we can see here, is that center. So very much building your foundation of this central data lake, which can provide the analysis and prediction capabilities, and it has to be able to support sufficient or have sufficient capacity and have the scale that you're going to be needing to have at the right price and performance. And then once we've got the data lake set up, then providing the capabilities potentially of moving the data out of the data lake to then support some of the other services that are around it. So we're going to be going into a lot more time and detail, or spending a little bit more time around the data lake itself and some of the services AWS have to help support that. And I'll be calling out the capabilities of lake formation and AWS Glue as part of that. And then as we go around, again, looking from 12 o'clock onwards, we've got the relational database service. If you've got some experience with AWS, you may have already been exposed to this. This can allow you to run their relational databases. For example, things like Microsoft SQL Server would be good examples, Oracle. So these are classic commercial databases that you want to run, and you outsource a lot of the heavy lifting, if you like, to AWS. Amazon also have their own Aurora database, which can provide compatibility with MySQL and PostgreSQL. So those would be the kinds of services that we may decide to run, as well as others. So there's others like IBM DB2 and MySQL, PostgreSQL, MariaDB. So there's lots of different engines that we can run, but it's classic relational databases. So if that's part of your use case, then absolutely that should come into play. Then we've got DynamoDB moving across to, I guess, what would be 2 o'clock-ish. It's really providing a NoSQL database, which can deal with the large volume of data and provide consistent performance as that volume grows. So if you're building an application that is needing to be significantly scalable beyond what you can have with a relational database, then DynamoDB may be a potential candidate. And again, some of you may already have some exposure to this if you have existing AWS knowledge. Moving on from that to what I guess would be about 4 o'clock-ish, SageMaker. A lot of talk, as I mentioned, in our industry. You'd think the only thing that's happening in the world is machine learning and artificial intelligence, but SageMaker is the service that we will be calling out that can provide ML or machine learning capability. Then towards the bottom of the picture, so I guess 6 o'clock, thinking about Redshift, which can provide data warehousing capability, so DW, data warehousing, OpenSearch, as we look beyond to provide searching capabilities. And then lastly, I guess what would be about 10 or 11 o'clock, Elastic MapReduce or EMR, which can provide a managed Spark or Hadoop environment, along with other Apache frameworks that you may be able to apply for doing your own extract, transform, and load capabilities. So there's a quick high-level overview of these services, and we'll dig into a little bit of detail of each of these services as we progress through the webinar. So starting our attention, I guess, initially with the data lake. And there's been other terms, I guess, that you may have had to consider, having maybe a data swamp or dark data, maybe where you don't have that visibility of all of the information. And really what the data lake gives us is that central repository that we can then provide access to for the analytics that needs to take place in conjunction with that data. So if you are implementing a data lake on AWS, you reduce some of the siloing approaches where data is not available to those that need to have access to it within your organization. So we can then collect our data from various sources, get it into the data lake, clean it, prepare it, catalog it, secure it, and make sure it's, of course, available for analytics or some of the other services that are around the center of the data lake. So going again into a little bit more of the detail around the data lake itself, really the design of the data lake is to have that central repository. So we overcome this siloed nature of data where maybe the different parts of the organization or the business has access to data that doesn't, and there's no visibility throughout the whole organization where it needs to be. So of course, being able to have that data centrally, which then means finding the data easier, so an easier access to that data, and then preparing that data. So as we're looking to prepare the data, maybe we're looking to prepare that for, again, machine learning, analytics as required. And the storage engine that we have that provides the capability, and again, a service that you may already be familiar with. Now, the storage engine is very much based around S3, which is Amazon's highly durable, highly scalable storage engine that provides the capability for your data lake. Then, as part of the cleansing, transformation of the data, the ETL, that may well be provided by AWS Glue, again, depending on your design and how you'd like to work with your data, but Glue can provide cleansing, transformation, so the kind of extract, transform, and load ETL capabilities as need be. You can also provide the cataloging, so again, finding the data in the data lake more easily, that can be provided by the capabilities of Glue. And then lastly, as we can see in the slide, the granular permissions. Having that central capability of storage of your data, we also want to be able to have a central place from where we can secure that data. And that's really where lake formation comes into play. Lake formation, as the name implies, helping you to build your data lake, but also giving you that central access control. So making sure that the right people have access to the data as they need to. So that gives us a little bit of a story around the data lake. And part of the process is getting the data into the data lake. So we need to ingest that data. So for example, maybe you've already got some existing structured data in, for example, things like the relational database service, RDS. You can bring that in through Glue, for example, or if you have data outside and you've got standard Java database connectivity, JDBC sources, you can use that to connect in and again, ingest that data. As I mentioned already, the storage optimization is provided by S3. So S3 provides that storage engine for our data lake. Again, highly durable, highly scalable storage technology, some of which, like I said, you may be using S3 for other capabilities already. It's going to be important we've got that security and governance. As I said, we may have sensitive data that we're dealing with in the data lake. So things like encryption of the data can be provided as part of the process with Amazon native encryptions using services like the Key Management Service, KMS, but also that governance capability, making sure we have the right people having access to that data using the lake formation service in particular. And then once the data is in the data lake, of course, we want to make sure that that data is available to those who need to have access to it. So providing that capability of data sharing and access. And like I said, that could be because it needs to be interacted with another service around the data lake, around those various points of the clock, if you like. But also, of course, maybe those systems and services that can interact directly with the data while it's in S3. So we'll talk a little bit about Athena that can provide that capability as well. So the data lake benefits, as you can hopefully see from here, is the fact we can have that data centrally located in the variety of data formats that you may have. So whether that's structured, unstructured, semi-structured data being stored in the data lake, cataloged, again, Glue can provide that capability to provide a catalog for that. All in open formats. So of course, you're not locked in, so don't have any vendor tie-in necessarily. Scaling to a storage that's probably exceeding what you could cost effectively manage on premises. And then the idea or the benefit of having the data lake also is that it can be stored in the data lake. And then when your analysis needs to happen, it can be moved from the data lake. So we separate out the storage from the compute and then moving that data to whatever compute resources we may need to have when we're ready to do our analysis. And having that flexibility of choice around, well, what's going to be the best tool set to analyze this and use machine learning, or maybe even processing the data in place. So keeping the data in the data lake. And there are integration points. I mentioned Athena, which can allow you to run a SQL queries against the data which stays in S3, or other services that can provide capability where the data can stay inside S3, but the analysis can happen from those other services. So I'll briefly talk about Redshift Spectrum when we get into the data warehouse. That would be another example, for example, as another example. Or maybe we're using something like SageMaker to provide machine learning, and the training data can stay in S3. So that hopefully gives you a little bit of an idea, I guess, around the data lake benefits. Again, I'm going to just share a couple of other links in the chat window. Let me grab these. These are a continuation, I guess, of the previous discussions. I guess it would be remiss of me to not have something that's got a reference to generative AI, because everything in the world seems to be all around generative AI. But I guess having that good foundational data strategy will help you if you're not ready now, or maybe you are, to really start to work with generative AI sometime in the future. So there's a couple of references around having that strong data foundation, which can help with generative AI, and another reference, which is just continuing to this theme about this modern data architecture. Now, the building blocks that we have for the AWS data lake integration and data movement, I've covered off, I guess, these services of lake formation, very much providing the permissions and management. S3, which is going to provide, as we've seen and as I've discussed a few times, I guess, the storage layer. Glue can provide cataloging as well as extract, transform, and load. So it's giving us a serverless ETL capability. And then, as of course I've mentioned, if the data is in S3, we need to maybe have some analysis without having to load it into a data service. Can we just query it in place? And that's really where Athena can come into play. But noting the other services that we're going to be going into a bit more detail around can interact with data that's in the data lake. So relational database service, DynamoDB, and other AWS purpose-built databases. Redshift for the data warehouse. I briefly mentioned Redshift Spectrum, so we can do our analysis while keeping the data potentially in S3, or we can load that data from S3 into Redshift for data warehousing. OpenSearch for monitoring log analytics and searching capabilities, and finally, of course, also SageMaker for machine learning. So really, the choices and the flexibility we gain by having the data in the data lake, of course, then we can make the choices that suit our analysis, our requirements at that point. So moving away, I guess, from the data lake, which forms that foundation, moving around the edges, so highlighting two services in particular. These are purpose-built databases which are commonly used. So as I mentioned, the relational database service, which supports 6 or 7 engines, depending on your perspective now. So these are various commercial or open source database engines that you could run, or even Amazon's own Aurora database engine, which has its own unique benefits that come with it as well. So relational database service, or RDS, it's really something that's going to be commonly used because we've got structured data maybe as part of our requirement. So and our applications have that requirement, we can host that on the relational database service. And then we'll also get into a little bit of detail around DynamoDB and just a bit of a comparison between the two. But what is quite interesting is those are not the only two purpose-built databases. We do have those as being the most commonly ones used. So relational, absolutely. Then we've got the relational database service, key value, that can be provided by DynamoDB, providing NoSQL capability and key value storage. But we've got support for services that can provide document in memory. So if you want to use an in-memory to get even faster response times, graph-based databases, for example, we have Amazon Neptune, time series. I think this has been deprecated. So the slide is still referencing what's called the Quantum Ledger Database, QLDB, not so commonly used these days. And I think Amazon have only made the service available for existing users. So yeah, you may be mindful about that. And also if we have need for wide columnar capabilities, we can take advantage of that as well. And if you need a reference on that, actually, I'll give you a couple of direct references in the chat. So if I just pop this one into the chat, and I might even just open that one up, because if you want to dig into the details of any of these data or analytic services, it's a good place to go. I'll just do a quick demo and bring that in. So that link I've just shared can give you a lot of insights, I guess, around some of those capabilities. So if you're relatively new to any of these services, you want to dig deeper. Okay, well, we mentioned Amazon Athena. We'll be talking a little bit more about Elastic MapReduce or EMR, Redshift for the data warehousing, etc., etc. It's a good way to, of course, find out about those specific services and data management. There'll also be references to additional services as well. So good place to find out more about those various services. And yeah, like I said, some links that I've been sharing have actually come directly from here, or the various analytic services that are linked in there. So again, you should see references to some of the services I've mentioned like Lake Formation, Glue, so on and so forth there. So really, for us, in this limited time that we're going to be spending together, the focus will be on these commonly used services, relational or key value through DynamoDB. Not so much around some of those other services that are available, as I said, if you have specialized needs. So focusing our attention, as I said, going back to the relational database service, RDS, reasons for doing so, you've got data that needs to be stored in tables, defined relationships between the tables, strong schema definition, referential integrity. So some of the characteristics that would indicate that you'll need to be using a relational database. Again, with the relational database, we'll get this centralized capability, so centralized database, and we can have ACID compliance, so atomicity, consistency, isolation, and durability, so ACID, so taking the database from one stable state to another. So these kinds of requirements that have been around if you've been in that kind of data space for a while, and supported by services that I've mentioned, Oracle, Microsoft SQL Server, etc. And now, of course, we have open databases and Aurora available to choose from as well. Also, getting the data in and out using standard structured query language, SQL, the need for us having strong primary keys that are going to be defined as part of the schema, so we can have consistency for the data that's being dealt with, and also having that data integrity that's provided by the ACID transactions. Why moving to RDS if you're working in the cloud? A lot of the overhead that a database administrator is really outsourced effectively to AWS. So a lot of the administrative tasks can be performed, so things like backups, maintenance. Also, it can provide a high level of scalability. So again, whatever your database requirements might be, maybe it can exceed what you have capabilities of on premises, while still also giving you high availability. So doing things like having multiple copies of the database across multiple, what are called availability zones, protecting you for potentially a failure of one of the Amazon data centers. It's a lot of features that you gain when running your relational database service in the cloud. Now, choice of using RDS, thinking about your access patterns, if you have strict table joins or need to enforce that data integrity, or you have ACID compliance, which arguably now we can also do with DynamoDB, so that's not the only requirement with ACID compliance. But scalability, again, as we need to support a certain level of number of transactions for our what is likely to be some kind of a transactional database, we can do so, making those changes in the cloud as need be, and getting a high level of performance with those databases. And again, whatever our storage, memory, CPU requirements might be, Amazon can provide a lot of those capabilities in RDS. In terms of integration, the relational database service can work with, of course, our data lake, with S3 and Athena. So Athena can also do federated queries. So not only can Athena query data that might be in S3, but it could also interact with data that might be in your relational database service as well. So we can join data between data that's in the data lake and that's in your structured data source, in this case, RDS. Moving on from there may be certain requirements that you can't meet with RDS or special use cases. So we're going to focus on one of the purpose-built databases, possibly one that you've come across if you have some AWS experience. Thank you, Karen. So that's Karen H, who just sent me a quick message. But yes, moving on to DynamoDB, this can provide a NoSQL key value database. So again, use cases for this, maybe you're building some kind of web application, you need to store some temporary state information, or that people's shopping cart information, whatever it may be. But really the benefit you have with DynamoDB is the fact it can scale. Relational databases have some limitations. Yes, they can scale, but they're generally reliant on vertical scaling, and there are some limitations in terms of what the maximum they can scale to. Whereas DynamoDB is very much going to give you horizontal scaling, so it can give quick response for potentially extreme concurrent users, so lots of people connecting into it, so internet scale type requirements, larger volumes of data. And again, one of the things that we can do with this is we've got lookups that we can apply against the unique identifier of the stored data. So we've got our primary key that we can specify that will be stored in DynamoDB, or for each item in DynamoDB, I should say. So access patterns, it's a bit more of a simplistic approach rather than having to define schema like we would with a relational database. We're really thinking about key values. So this gives us flexibility in the schema. It also means it's very partitionable, so it can horizontally scale, spreading that data across the systems behind the scenes that Amazon provides. This is what's referred to as a serverless service, so you don't have to build and define what your requirements might be. And again, off the back of that, virtually any size tables with horizontal scaling, auto scaling, also replication of that data across the world potentially with what's called global tables. So again, somewhere where you need ultra fast response is something you're going to get from a performance perspective with DynamoDB. And again, you can also support ACID transactions with DynamoDB now, so it's not a requirement to use RDS if you're still looking to have ACID transactions. So yeah, business use cases may well be included depending on what your performance requirements might be. Few things just to highlight in terms of the benefits. It's serverless, so again, we don't have to really think about our compute capacity. It's cost optimized, so you can pay for what you use and can support mission critical workloads while still giving you that strong level of protection of your data. So the data security is still there as well. In terms of DynamoDB integrating with other sources, it can connect into our data lake. We can export data from DynamoDB into other services as part of this modern data architecture. and the data can come from or be exported into S3. So again, direct integration between the DynamoDB service and these other services. So that's two of the purpose-built databases, and they're the common ones a lot of organizations will continue to use as part of their architectural designs. Relational databases where required, DynamoDB where required. You may notice my slide jumps. So we go from those two database services there into the next one. I will come back and cover off SageMaker in a later slide, but because I guess we're talking databases, it makes sense that part of your strategy includes what are we going to do with regards to a data warehouse. So the data warehouse was the go-to service or go-to concept, I guess, going back a few years, because it was a single source of truth. Now you could argue our single source of truth might initially be our data lake, but then for optimized analysis, we might put it into a data warehouse. So this is where Redshift will come into play. So Redshift can provide that data warehousing capability. And unlike a classic relational database like RDS that we've looked at, it can provide performance at scale and overcome some of the storage capacity limits. So now we can have all of our data available for analysis purposes. It can have our structured and semi-structured data that's actually being stored in there. And it can actually, because of the nature of how it works, add more capacity. So this idea of concurrency scaling, when you need to throw more queries at the data warehouse, the service can provide extra capacity to be able to cope with that. And again, minimizing of data movement, we can load the data into Redshift. I mentioned earlier on, we've also got Redshift Spectrum, so we can actually have the data being stored in S3 and then do the analysis using Redshift as need be. And because of the nature of how Redshift is designed as a data warehouse, we're using familiar SQL tools to basically interact with that data set. So features-wise, this can provide us our analysis capability. So again, across all of our data in the data lake and other data sources, we can have that single source of truth with consistent performance. And as I said, maybe having that data being imported or loaded into Redshift, potentially also having that analysis happening in S3 using Redshift Spectrum. And we have options in terms from a costing perspective, whether we'd like to use this as a serverless engine, which can provide a pay-as-you-go capability, or we can have dedicated systems that could be then hosting and supporting our data warehouse. Highlighting some of the benefits, consistent performance at scale. That's one of the benefits of how Redshift has been designed with its custom hardware that it's working with. So it can provide consistent performance at any scale. As I mentioned earlier on, structured or semi-structured data, decoupling of the storage and the compute. So we can have our compute being provided by Redshift, but then having the storage maybe potentially added as we need to. Security and regulatory requirements can be met when storing that data in Redshift. The integration it will have with other AWS services, interacting with, for example, the data lake S3. And again, very much like the relational database service, the Redshift data warehouse reduces your administration overhead of managing and maintaining a data warehouse. So again, reducing your total cost of ownership. Benefits from a cost performance perspective, and the data can be queried using the various services as need be behind the scenes, so we can get that query at the source without having to move the data. So again, I mentioned Redshift Spectrum. So at that point, the data can happen against the data that's at S3, or we can have federated queries. So Redshift can make its connection to the remote data source and then retrieve the metadata and then query that data again in place. So we can have this idea of federated queries, very similar to what I mentioned earlier on with Athena, keeping the data in place and then using Redshift for, in this case, the analysis, not Athena, as I looked at earlier on. So a couple of times I've mentioned Redshift Spectrum. So Redshift Spectrum, capabilities-wise, will allow you to run your analysis, but keep your data in S3. And as you need to maybe reduce your storage of Redshift, you can export your data to the data lake. So this is one of the benefits of having the data lake at the center of your architectural design. Federated queries that I've mentioned, of course, keeping our data wherever it might be, and then analyzing that data in Redshift and then connecting into the data source accordingly. If you have multiple Redshift clusters as they are, you can share data. So this gives you a secure way of sharing the data between those different clusters. You can provide also machine learning capabilities. So it's an interesting idea also within Redshift that you can provide ML capabilities directly using SQL statements. So without you having to go through and train using machine learning services like SageMaker that we're going to come on to, you can run SQL queries, or SQL statements rather, I should say, to create and train the models, and then use those models to make predictions. So ML built directly into Redshift, essentially, without you having to work with an external machine learning service. And then also copying data from DynamoDB to Redshift is, again, also possible. So if we have some of our data being stored in DynamoDB, but we need to bring it into Redshift for us to perform our business intelligence, our analysis, again, possible to do so. So we can join tables that are in DynamoDB with Redshift. So that really covers off, I guess, these building blocks. You again may have noticed there's a bit of a skip as we move to the next one in the slide. This is Elastic MapReduce, or EMR. So some of you maybe historically have had to support very large data sets that you're then having to use optimized capabilities to do your analysis. So maybe things like Apache Hadoop or Spark. And really what Elastic MapReduce allows you to do is, rather than you having to build and manage and maintain clusters that are supporting those kinds of services on premises, running those in the cloud. And the ability to provision those big data clusters in short periods of time, or even using serverless capabilities, which is a relatively new feature of EMR as well. So again, getting the level of resources that you may need to do for maybe performing your own extract, transform, and load or analysis capabilities by using EMR. And integrating, again, the whole idea, I guess, of having those that capability of connecting to the AWS data store of choice that EMR can interact with. So again, it can interact with your data lake, it can interact with data that's in DynamoDB, for example, as need be. So with EMR, we've got a few choices as to how we want to run that. It can run on top of, so Elastic MapReduce can run on top of the Elastic Kubernetes service. So we can have a Kubernetes-backed service that can provide the analytics and big data service capabilities. Or we can have our own clusters that we're going to be building. These could be running for a short period of time, so they could be transient clusters, started, do the data analytics, and then destroyed as need be once the results have been output to our data lake into S3. Or we can have long-running clusters. If we're doing regular analysis jobs that require us to have compute capability at all times, we can have an EMR cluster that's going to be long-running. And lastly, of course, we've got this relatively new idea of EMR serverless, so we don't have to think about provisioning and what our capacity requirements might be. We can pay based on a consumption model, very similar to a lot of the other services that Amazon have that are serverless. So benefits of EMR, we're getting that scalability to be able to deal with your large data sets. A few choices in terms of what I just mentioned that can make it very cost effective. Have them temporary clusters doing what they need to do, so transient and then destroyed, or using serverless. Flexibility depending on the workloads or the frameworks that you're needing to support. So it's got support for Hadoop that I mentioned earlier on, Spark, Hive. So if you're using some of these open frameworks for your analysis purposes, they are available within EMR. So again, giving you that flexibility. Integration with S3, DynamoDB, other AWS services, while having strong security for the data that's needing to be protected using services like encryption as need be. And then interacting with the EMR cluster, we've got many ways that we can interact with AWS services, whether it's through the command line interface, whether it's through the web interface, interacting with that data and having some automation as need be to do your analytics purposes, for analytics purposes, I should say. Storage engines that we can have. So again, EMR, as I mentioned, can interact with S3, Redshift, DynamoDB as the storage engine, or it can use the native Hadoop file system as need be on those systems that are being provided by Elastic MapReduce. You can do integration with SageMaker for machine learning, the data lake. So if you're going to be having people executing data against EMR, You can use lake formation to control, access control, and determine who can do what through lake formation when interacting with that data through EMR. Database integration, so we've got some open database tools like Scoop and Hive that are supported, and you can extract and process data into Redshift, RDS, DynamoDB. And then lastly, maybe you've got the need for analysis of logs, and in terms of what's happening in EMR, you want to take those logs and make them available to OpenSearch, which is a service that I'll talk about shortly as well. You can use this for a lot of your DevOps, logging, and analysis and operational data. So funnily enough, talking about OpenSearch, it can provide, as the slide suggests, application monitoring, log analytics, and search capabilities. Some of you, if you've been around, maybe you've used capabilities from the Elasticsearch Logstash Kibana or Elk Stack. OpenSearch is formed as an open source tool based around Elasticsearch. So if you're not familiar with it, it's something that is an open capability or open service that can provide similar capabilities. It's a fork essentially from Elasticsearch. So providing search capability, maybe using this for your security incident and event management, so your SIEM tool set that you may be using from an operational perspective. Operationally, monitoring applications infrastructure, and also providing observability of what's happening across your different systems and services. So again, helping you with threat detection, incident management, these kinds of things can be provided by OpenSearch. And because it is a service that is a managed service from AWS, it can simplify your process of getting OpenSearch up and running. So they can take care of the setup and configuration, event monitoring and alerting. Like I said, it can provide capabilities of interacting with a lot of your other operational databases, integration with other open source tools as need be, and like I said, potentially providing your visibility from a security perspective and controlling access to OpenSearch to your different applications through secure mechanisms using your Amazon VPC, Virtual Private Cloud, along with your restrictions that you may put in place off the back of that VPC. It's a managed service, so therefore a cluster is provided for you and fully managed by the OpenSearch service. High security data or high security can be provided for your data. So again, having compliance and regulatory requirements, encryption can be applied across the data that's being searched or stored in OpenSearch. And using this, like I said, for open source solution for machine learning, alerting, and visualization, helping with operational investigation, security related or operational considerations. And then it means, of course, that taking advantage of OpenSearch, you can focus on what your requirements might be, similar to what the other services provide. You're outsourcing a lot of those requirements and the heavy lifting, if you like, to AWS. Integration points. So integration points from RDS to OpenSearch or DynamoDB or SageMaker. So again, all of those capabilities can provide ingestion into OpenSearch as need be. So there's pretty much a lot of the considerations and a brief overview of most of the services. You can see now we've gone back to, I guess, 4 o'clock of this circle, SageMaker. A lot of talk in the industry. I'm sure you've heard a lot of around ML, AI. And I guess really where SageMaker can help you with this is in this middle in terms of the platform services. So if you need to build machine learning platforms that can then, or machine learning capabilities that can integrate with your data sets that you've got with this modern data strategy stored in those various data sources, SageMaker can provide that capability. Now, there's a couple of other things that are mentioned here that we won't get into much on this session, via application level services. So if you want to take advantage of ML capability at the application level, you can take advantage of those services at the top. But if you're looking to build and run your own training and model creation, that's where SageMaker will come into play. And it supports some open frameworks like TensorFlow, PyTorch, Keras, MXNet that you can then take advantage of for your machine learning capabilities. I might just break this slide a little bit and actually share another interesting reference. Let me just grab this from off screen because the AWS ML stack, I found a slightly up-to-date one, which includes the same things that we've just been looking at there, but it also brings into play a couple of other discussion points around SageMaker Canvas, which can provide no-code analysis for ML. Also, SageMaker Studio Lab, very good for learning about machine learning, along with SageMaker Studio. And again, references in terms of what it can provide there. So I might just post this picture. It's directly from the AWS website. So I'll just post this picture into the chat if you want to find out more from there. And at the bottom of the picture, it also covers off something you will hear maybe a little bit more around over the coming months and years. AWS actually have their own custom silicon that's designed for training purposes. So AWS Trainium. I guess you can draw an analogy very similar to how Apple have created their own silicon for their devices. So Amazon have created custom silicon that's designed for training and machine learning, and also for inferencing or predictions. So Trainium and Inferentia are also being referenced there as well. So just moving back to the slides, let's just cover off what SageMaker brings to the party. So machine learning capabilities, absolutely. And what this can help us with is getting that data in for the purposes of training. So as we need our data to be used for training, so looking for patterns in the data, SageMaker can provide that capability by working with your data that's outside in S3, for example, provide that training capability. And once trained, can provide inferencing, predictions, having been trained on those various patterns, then providing predictions for what the data points might then suggest that you're then using that in a production environment. Capabilities wise, very, very capable. If you're running supervised model training where we've got data that's been labeled and we're then putting that data through SageMaker and then predicting on data that hasn't yet been labeled, preparing the data, storing the various features that you may have there, looking out for bias and explainability, quite an important thing when we're starting to work with machine learning, having those kinds of capabilities, along with the visualization of the data. There's built-in algorithms that you can work with that SageMaker supports, or you can bring your own algorithm. So that's another capability that gives you some flexibility. But the training, the debugging, the tuning of the model, and then monitoring ongoing can all be provided by SageMaker. And then when we're ready to use that in production, we can deploy those models into production and provide that inferencing, those prediction capabilities as need be. So again, very much a multi-purpose tool set for machine learning. And some of the benefits that we have there, it's a fully managed service that can provide hosting of the endpoints, what's going to provide those predictions, but maybe our applications need predictions. If you're in the financial services industry, we're predicting maybe fraud detection, for example, or predicting fraudulent transactions, providing the endpoint that's going to then take that and then your application can do something with it. So SageMaker Studio providing you an integrated development environment, an IDE that can be used for machine learning, integrating with your operational, your DevOps approach that you're taking for machine learning, so ML ops, working with the code that you've created, making sure that that's going to be available to work into production, and then even getting recommendations in terms of what the deployment should look like and what your requirements might be for it. So again, a lot of capabilities built directly into SageMaker that you can take advantage of for ML. And coming back into our discussion around integration of this particular service with our various data sources, connecting into EMR, S3, and then using this for the analysis of the data as need be, interactively using SageMaker notebooks as need be. And again, you choose your framework that you're using for machine learning and then perform your building, training, and deployment as need be. Now, just before I move away from SageMaker, again, big discussions, I guess, that we're having. And I know I'm not going to try and turn this into a generative AI discussion because you've probably heard a lot about that over the recent past. But just bringing into the equation SageMaker and where it fits with some of the other services you're going to be hearing from Amazon. Now, if I can just pop something into the chat. So it's an article from about 7 or 8 months ago, but I think it's important just to be having the awareness. SageMaker can give you a lot of machine learning capability. So you can build your own what are called foundational models as need be foundational models are those pre-trained models that you can take advantage of. So you want to build your own FMs, your foundation models, SageMaker would fit there, as you can see in this architectural slide for generative AI. Also mentioning, of course, Inferentia and Trainium, as I mentioned earlier on. But the other service that outside of the scope of these discussions today, but Amazon Bedrock, something you'll be hearing a lot of if you haven't already from AWS, that can provide tools to interact and provide to work with the foundational models that AWS will provide, or large language models, LLMs, and then the applications that can then take advantage of those. So again, if you haven't been hearing a lot around Amazon Q, this is the application layer that can provide interaction with and for your generative AI. So there's a reference that I want to just post there and not get too sidetracked necessarily with generative AI, but of course just to bring it in to have an awareness, I guess, of where SageMaker fits in relative to the other AI ML services. So returning back to the slides, if I can. Now that we've seen the various components that may make up this modern data architecture, with the data lake at the center, lake formation that can provide the governance and the interaction with those various data sources, S3, which provides the storage for it, and Glue that can provide extract, transform, and load and cataloging capability. Really what we can make some decisions around is strategically, we might make decisions because of the tight integration between the services around the edge of the data lake, having this outside-in data movement. So moving data from our data warehouse, for example, if we're needing to unload it, take the data out of the data warehouse and then unload it, put it into our data lake. So for that, when we need to, maybe we can load it from the data lake into SageMaker, for example. So we've got an outside-in data movement, which can happen. So again, because of the integration between these various services and the data lake, but equally inside out. So as need be, once the data has landed in the data lake, we may need to get that data out. So we want to bring that data into Elastic MapReduce because we're using some Spark jobs that we need to run against the data set, or we'd like to run some machine learning. So of course we can make that data accessible to SageMaker. So really strategically, if you've got the data lake at your center, it can have the data arriving into it. So this outside in that I first showed, inside out, or due to the fact that there are integration points between the various data sources, so RDS, DynamoDB being made available to SageMaker, we can use this around the perimeter data movement. And I guess that's the benefit we have, is we have choices, we have flexibility, depending on what we're looking to achieve and how we'd like to analyze and work with that data. So really wrapping up this AWS modern data architecture, before I open up for questions, also posted a few other resources that I think will be useful for ongoing learning. So looking towards the top, relational database service, a managed relational database that AWS can provide, supporting engines including Amazon's own Aurora database, Microsoft SQL, Oracle, along with others, IBM DB2, etc. So again, our requirements are for a relational database. There's our purpose-built data solution for that. DynamoDB for a NoSQL if we're doing things at scale using key values. So examples, again, internet scale, games, for example, shopping cart applications. Those would be good use cases for DynamoDB. Consistent performance at scale. Then we moved into Redshift, which can provide the data warehouse capability. So loading our data into Redshift so that we can do all of our analysis at that point in time with Redshift. Elastic MapReduce, which can provide some services for managed Spark, Hadoop. If our requirements for data batch processing and analytics require some of those Apache services, can provide those capabilities. OpenSearch for providing analysis, visualization of our data sets using an OpenSearch capability, and then combining that with things like Kibana for visualization, SageMaker providing the ML capabilities. And of course, in the middle there, if I haven't already mentioned it, that gets the starting point. Really just make sure we've got S3 at the center with our data lake formation for the governance of the data, Athena providing SQL capabilities of that data, and Glue providing cataloging and extract, transform, and load capability. So there's a summary of everything there. Just before I go into some of these resources here, bear with me a second. I've got a few resources I wanted to share in the chat window that may be useful from a practical perspective to continue your learning. So of course, we've very much scratched the surface in terms of what these services can do. So if I can just provide a series of workshops, if you'd like to get some practical hands-on experience, there's a good resource that I've just shared into the chat window called workshops.aws. And this particular website provides a list of various workshops, so hands-on experience with these and a lot of the other AWS services that you can see from here. Now, you will have to provide your own account, so maybe your company will provide for you a Sandpit account if you want some practical experience, if that's the kind of role that you're in. But as you'll see here, if I just search for example, let's go Redshift, I'll just choose that one. So you'll see a Redshift Immersion Day workshop, along with other things as well. And for these workshops, it will provide you guided instructions on interacting with the various services. Just be mindful of the fact that if you are running this yourself, you'll have to provide your own account. So like I said, maybe your company will provide you one for you, or if you're using a personal free tier account, just be mindful at the end of it, you want to clean everything up so you're not left with any ongoing costs. So there's a series of these that I'd like to share. So I've kind of put together a list that relate to the services I've been talking about today. So bear with me. I'll just pop these all into the chat window. So for the various services that we've been discussing today, I've got some practical links. I'll just pop into the chat window. I might have to just break it into two sets. So there's as far as Redshift. And then I've got SageMaker, EMR, and OpenSearch as the next ones that are appearing in the chat window. So hopefully that'll give you a starting point if you want to continue this theoretical learning, depending on your role. If you want to get some practical experience with these various AWS services, that may well be a good starting point. And to continue, I guess, on that same theme, if you want a bit more of a guided walkthrough and labs provided, here at Bespoke, we provide training courses. So I'm one of the instructors that delivers some of these training courses. So you can see here, we've got various training courses from fundamentals of AWS, so AWS Technical Essentials course, which is a good grounding, not necessarily in the data space, but certainly in understanding AWS's core capabilities. And then one-day courses around data lakes, batch data analytics, which is around EMR, streaming, which is something we haven't actually covered today, around Kinesis. And then Redshift, we've got a one-day course. There's also a three-day course that we've got, which is around data warehousing. So there's either a one-day course or a three-day course on data warehousing. And then, again, calling out specifically SageMaker's capabilities on this three-day course here. And over and above that, we've also got some courses being referenced in here, which will help you build your knowledge through Skill Builder, Amazon's web platform for learning. So if you want to look at have a bit of a hybrid approach of using some of the instructor-led training courses that we run at Bespoke, plus some of this digital training, some of which is free, some of which is a paid subscription. But yeah, all of this information is on a learning pathway that we've got on the Bespoke website. So I'm going to share a link to that. Similar kind of thing actually also for the Amazon, the AWS Certified Machine Learning Specialty Certification. Got links around that. So if I can provide you this link here, this will give you some resources if you want to find out more about those one-day training courses. And funnily enough, those one-day training courses, we do have some in the offing in the coming months, as you can see on this slide here. And those training courses will have a combination of theory and lab exercises, kind of classic instructor-led training, which is done these days virtually. So of course you can attend online as you have done for the Zoom session, the Zoom webinar we've had today. But yeah, various training courses, like I said, which have the associated labs. If you want to find out more information, feel free to just check out the Bespoke website. And also, if you want to find out more about data-driven approach in the cloud, we've got a blog article that I'd like to just call out as well. So I'll just give you a link to that, which is in my slide. If you want to read more about this. And really, I guess this is the opportunity. If you have any questions, I've been keeping an eye on the chat window. I know I've gone at quite a fair pace to get through the content. But if you have any questions, feel free to pop something to the chat window. I'll react accordingly. And while you're thinking about those questions, or I'm looking for those to come through. So Ade, yes, Redshift is compatible with SQL database. It's, again, built around SQL. So you can import your data from your databases that you might have, your data sources that you might have that are on SQL. So your structured data sources, bring those into Redshift. And Redshift uses standard SQL that you can do for your analysis. So from both perspectives, getting your data in and also doing your analysis of your data once it's in Redshift, very much SQL compatible. And in fact, if you have a check of that workshop that I shared, that Redshift one, Redshift immersion data, you'll find there'll be a little bit of work that you would do with that one. And I know we also do it on the training courses as well, but you can see a little bit more information about analysis and loading of your data. You'll see, like I said, some good resources there. So you don't even necessarily have to run through the whole exercises that are in this Redshift immersion labs, but just seeing what the capabilities are, you may find it's very, very useful as well. But it's very much based around that structured design that we'd have for the data warehouse in Redshift. So hopefully that addresses your question. Feel free if you want to repost or respond. Yeah, so syntax compatible in terms of actually being able to do your analysis, if that's what you mean in terms of the SQL capabilities. Yes, very much so. So yes, you can find the SQL capabilities, and I'll see if I can find you a quick reference on this. So aws.amazon.com/Redshift. What I would do is I'll direct you through to the Redshift documentation. So if I can just find the Redshift documentation, that's where you're probably going to find a lot of the specifics. And let me just grab that up on screen from the Redshift Database Developer Guide. And Greg, I've just seen your question about Code Whisperer. I don't know is the answer to that question, if I'm honest with you. But if I can post this in response to your question, Ade, this is where you're going to find out more about interacting with data in Redshift. So what I would expect to see in here is going to be the query. So from this querying and sharing links, you'll hopefully find, actually querying spatial data is not what we're specifically looking for, but yeah, querying data with federated queries, external queries using Redshift Spectrum, querying data across different databases. So if that's what you're looking for, and also the SQL reference. So if you're looking for the syntax capabilities, yeah, you'll find a lot of that in this link that I've just shared in chat. I might just pop this one to there. But Greg, yeah, I have no insights. I can't share anything more about Code Whisperer other than knowing, as you've already suggested. So Code Whisperer, so it's kind of outside the scope of what we're covering off here. Code Whisperer is going to be rebranded underneath the Amazon Q Developer, which I know I kind of posted a little bit of a link around generative AI. I couldn't give you any insights personally in terms of when that's coming to the Sydney region. So I'm not 100% sure on that myself, if I'm honest with you. That's something I would probably suggest you try logging directly with, if you have an account manager at AWS, or getting in touch with them. I don't have any information, but what I might be able to do, let's just have a look. So Amazon Q developer regions. I know, of course, they do specify which regions. So supported regions for Amazon Q developer. And what generally tends to happen, oh, okay. So Amazon Q developer is in the management console, and it goes to show you, I haven't done much with this myself, but looking at that, Q developer, which is the new name for Code Whisperer, based on the link that I've just shared here. So I might just share this link about supported regions. It does seem to imply it is available, but it's not something I'm much of an expert on by any stretch, but the implication is Q developer is available in Sydney now. So hopefully that helps. If there are any other questions, feel free to throw that out. I'm happy to kind of hang around for another couple of minutes, but I have hit the hour or so that I was initially looking to spend. And thank you so much for investing your time, your patience. Hopefully it's given you a little bit of an overview of the modern data strategy and what that may involve in AWS. and some resources that may help you with your continued learning. But all the best. Thank you so much for spending the hour with me with that overview. Please feel free to share any feedback in the survey that will happen as you close the Zoom session. Enjoy the rest of your Tuesday, whatever time that might be, just after midday if you're in Australia, just after 2, I guess, if you're in New Zealand, wherever else you might be. So enjoy the rest of your day. Thanks so much for attending. Maybe see some of you in the future.